Hey everyone, so hopefully you can hear me all right. My name is Shreyas Subramanian. I'm a principal data scientist from AWS. I'm joined here by my colleagues from AWS as well, so we're happy to stick around if you have any questions later. Today I'm going to talk about the 3Ds of generative AI. This is not going to be about AWS, so hopefully this kind of educates you in what's Gen AI good at and what is really not good at even today. So next slide. Quick view of the agenda. So I'll give you kind of my interpretation of what the 3Ds here, dull, dirty, and dangerous sides of Gen AI are. Maybe leave you with a couple of tips on how you can cut through the hype cycle and look at what Gen AI is good at for today and how you can educate your teams and work with your teams on applications that use Gen AI as well. Next. So we'll start off with the Gen AI stack, right? So regardless of what cloud you use, these three kind of fundamental layers exist today. Going from bottom up, we have the infrastructure layer where you can use data storage and management to manage your everything from your training data to your prompts and traces of your application. You have vector databases that are used for typically RAG or retrieval augmented generation tasks. You also have compute infrastructure that's used for fine-tuning as well as hosting some of these models. One layer up, you have the model layer where you have a choice of third-party as well as proprietary and open source models that you can choose from based on your application. And you're also deciding at this layer, do you want to directly integrate your LLM or fine-tune your LLM or foundational model to kind of make it more relevant for your application. And on the top layer, you have your application development frameworks, where we're seeing a different side of application development, where you're looking at tools and services that are useful for RAG and agent-based simulations, and these are all really specific to the Gen AI stack. Next slide. So we'll start off with the first D, which is the dull tasks. So what I mean by that is how do you automate repetitive tasks, and these are generally in the category of what Gen AI is really good at today. Next. So first of all, how do we know that some of these models are good, right? So one of the things that we currently rely on heavily is public benchmarks. So public benchmarks are usually released by proprietary model providers as well as confirmed by the open source in academia. And you'll see on the right here, you'll see a table of kind of the top ranked models. You've probably already used or heard of some of these models. So GPT-4o from OpenAI, you have Gemini from Google, the other GPT flavors from OpenAI as well. I want to include also an open source model at the end, which is Nemotron that you see on the bottom. And the importance of kind of showing this is the gap between proprietary models and open source models are kind of closing. We still see proprietary models that have access to large amounts of infrastructure for fine-tuning and training do have a lead over open source models. But we're kind of looking at these ranks in two different ways, right? So the first column there, which is the LM-SIS rank, is a human evaluation, right? So when humans kind of interact with a chatbot, they're kind of preferring one response over the other. And the LM-SIS rank basically ranks models based on how well these models responded and what customers basically preferred, right? And the academic ranks are based on really specific tasks. So it could be common sense reasoning, it could be math, it could be multiple choice question and answers. And there is a set of these benchmarks that we're constantly testing these models against, and these benchmarks are also growing. So you'll see a general trend between starting off with GPT-4o and going down to the open source models. Beyond just quality benchmarks, we see a lot of customers that we support also doing latency and throughput benchmarks and cost benchmarking, right? So that's how we generally know these models are good to start off with. Next slide. And we also know just through our own interaction, I'm sure all of you have tried out ChatGPT or Claude AI or Perplexity or the U.com and all of those things. And what we know Gen AI excels at, based on just our own anecdotal evidence, as well as we've helped customers in the startup space, in the enterprise space, and we continue to help CDAO and DoD in their mission as well. So what we know so far is that general Q&A, brainstorming, and drafting documents and emails, this is something that Gen AI models generally hit out of the park, right? Things like that's slightly more advanced, like maybe generating training data sets and synthetic data that can be used for simulation or for fine-tuning. Also using coding copilots, those are getting a lot of attention and therefore kind of do better at today's benchmarks, right? And we know this kind of frees up human time to focus on higher level, more creative, more strategic work, and that's for sure something that Gen AI excels in. But kind of shifting gears a little bit, maybe we can go to the next slide. Thanks. So we'll go to the second D, which is the dirty side. We're going to talk about bias, toxicity, and responsible AI, and these are important angles to kind of evaluate your LLM as well. Next slide. So one really curious thing is people are often surprised as to when LLMs hallucinate, or in this case, hallucinate in a particular direction where it talks about hate speech or derogatory language usage, you have toxic kind of conversations. There's also stereotyping. There's direct or indirect discrimination that's happening with the dialogue, and also if you're asking about, and you've probably seen these examples of how do I build a bomb, and it kind of faithfully answers. So there's these kind of behaviors that are kind of undesirable, and we want to know how you can detect them, right? So a couple of ways to detect them. On the top right is embedding-based tests. So what you see is there's a prompt given to an LLM. This is a doctor, and that is embedded into vector space, and you want to see whether it's closer to a woman or a man, right? And typically we see that it's closer to a man, right? The second example there is kind of a completion test. So we're trying to give the LLM tests like she is good at dash or he is good at dash, and what we see is more often than not she is good at arts and some of the more soft skills, and more often than not he is good at STEM, which is not true in general, right? So it's kind of surprising to most folks as to where the LLM learns this, but this is purely from the data and the distribution that's in there already. Next. Yeah, and so hopefully we're getting better, right? So this is a screenshot. I don't expect you to read the actual Python code in there, but this is from December 2022. A couple of years back when things were kind of blowing up and the hype cycle was getting started. But the instruction is to write a Python function to check if someone would be a good scientist, right? And ChatGPT in this case responded, if your race is white and your gender is male, then you're a good scientist, right? So hopefully you're getting better. I mean, it's 2 years, it's more data, it's billions of dollars of investment. So if you hit next, this is a screenshot from yesterday. So we see that it's better, but it's not yet as good. It's still kind of biased in some way. So it kind of prefaces its response by saying, you should not really do this, but if you really wanted me to do this, I'll give you some code. And the code that it gives out is that if you're an Asian and you're a female, then you're a good scientist, right? So it's not really getting better, but it is a little more aligned, but the alignment objectives are also defined by us, right? Next. So we'll end with a couple of examples on what dangerous means as a third D. And here, these are state-of-the-art models that catastrophically fail in certain tasks, right? Next. Yeah, so let's look at maybe basic reasoning first. So we kind of have the illusion when we talk to these models that these models are really intelligent, and we kind of anthropomorphize it as well, where we say it's really intelligent and it's probably smarter than me or smarter than my kid. But here's a simple test, right? So there's a recent paper that tested it on what's called an Alice in Wonderland benchmark. So the Alice in Wonderland benchmark basically says Alice has n brothers, and she also has m sisters. How many sisters does Alice's brother have? And if you kind of think through it, you'll know it's the number of sisters plus 1 because Alice is another sister. So it's kind of easy for us to decode that. But if you look at GPT-4o, getting it right about 65% of the time, and there's a steep drop to Claude Sonnet, which gets it right about 1% of the time. This is the same kind of failure that we see with simple tests like I have a coin that's heads up placed on a table. I flip it twice. What's the side that it's on right now? We know that it's heads, but very often even GPT-4o and Claude will get it wrong 99% of the time. So it's important to think of these things when you want to integrate these with your actual application systems, right? Next, here's another example. This is a prompt to GPT-4o and says, I can't perform this surgery because I'm the boy's father. How is this possible? And GPT-4o will say, this is possible because you're the boy's mother, right? So it's kind of a complete breakdown of reasoning and simple common sense. Next. For us as well, math is hard, but for LLMs, seems like it's much harder, right? So when we're asking LLMs to both interpret documents as well as do some basic math on it, so here's LLMs that kind of fail at multiplication and division, and here you see the same kind of drop off. It's a bad report card that you see on the bottom left there in terms of math as well. Next, and the last one is LLM as a judge, which is a popular concept right now, where LLMs are being used to evaluate other LLMs or other human responses. And we see that it's often wrong, it's often biased, it's often preferring like the first or the second answer. It's preferring answers that is generated by the same family of models, and so you would want to be careful with some of these things. Next. So what do we do to actually detect and kind of correct for these failures, right? Next. Couple of major points. You want to trust the public benchmarks, but also verify on your own. You can verify on your own with your own benchmarks, which is even better than doing it as a repetition of public benchmarks. There's a bunch of techniques that are coming up right now, which are basically grounding responses of LLMs and avoiding hallucinations. It comes from tool use and agents. For example, if you have a simple math problem, you want to use the calculator as a tool. All the way up to if you have a forecast or a weather simulation, you don't want the Gen AI LLM to do that. You just want to interface with a tool that already does that. There's also pre and post checks for guardrails and a few other ways that you can help with operational testing before you integrate it with your applications. And the last one, next, is safety testing, which is really important. We saw the dirty and dangerous sides, but you can do safety testing on the model side as well as the application side. On the model side, you want to clearly define policies that you feel is safe. And sometimes you want to detect toxic conversations as well. And so in this case, you don't want to prevent toxic conversations from even being input to the LLMs. So it depends on your safety policies. You also want to do automated testing and red teaming, and where red teaming is basically trying to discover vulnerabilities from your LLMs automatically. At the application level, you want to do an end-to-end trace, and you want to see the entire path that your prompt flows through. You want to do invocation level tracing as well and maintain internal documentation for your teams, right? So your application might be very different from the general Gen AI application, and also allow users to provide feedback. And lastly, humans are still kind of in the loop, and so you want to use humans in the loop for verification as well as operational testing and usage. So with that, I want to end my talk, and we're going to be sticking around. Thank you so much for your attention.